Have you ever wondered why resistors are so important in electronic circuits? Welcome to the intriguing world of resistors, a crucial component that makes our electronic devices function as they should. Be it the television you watch, the mobile phone you use, or even the toaster that crisps your bread every morning, resistors are there, silently doing their job. Resistors, in the broadest sense, are like traffic controllers of the electronic world. They regulate the flow of electricity, or current, within circuits, ensuring it travels where it needs to go and at the right speed. Without them, current might rush uncontrollably, causing havoc and potentially damaging our beloved devices. So next time you're using your favorite electronic gadget, remember there's a world of resistors working tirelessly behind the scenes, managing the flow of current to ensure everything works smoothly. So resistors are everywhere, but how exactly do they work? Resistors, in essence, resist the flow of electrical current. They're like the brakes on your car, slowing down the zippy electrons that make up the electrical current. This slowing down, or resistance, is incredibly important in a circuit. Without it, the current would race unchecked, potentially damaging other components. Now, how do resistors manage this feat? Well, they employ a basic but fundamental principle known as Ohm's law. Named after the German physicist Georg Simon Ohm, this law states that the current passing through a conductor between 2 points is directly proportional to the voltage across the 2 points. In other words, if you increase the voltage, the current also increases. However, if you introduce a resistor into this circuit, it will reduce the current for a given voltage. This is where the magic of resistors comes into play. By adjusting the resistance, we can precisely control the amount of current flowing in a circuit. The higher the resistance, the lower the current. The lower the resistance, the higher the current. It's as simple as that. But how do we know how much resistance a particular resistor provides? That's where resistor color codes come in. These are a series of colored bands on the body of the resistor, each representing a different value of resistance. For example, a resistor with a brown band followed by a black band and then a red band represents a resistance of 1000 ohms or 1 kilo ohm. The first two bands represent the significant figures, while the third band represents the multiplier. The colors range from black to white, each corresponding to a specific number. There's a mnemonic to remember the sequence. B.B. Roy of Great Britain had a very good wife, where the first letter of each word represents a color. So resistors are like the traffic controllers of electricity, managing how much current flows through a circuit. In the world of electronics, they are the unsung heroes, quietly doing their job and keeping things running smoothly. To sum up, resistors are crucial components in electronic circuits. They play a pivotal role in regulating current flow and maintaining the balance within the circuit. By creating resistance, they control the amount of electricity that passes through, preventing potential damage and ensuring the smooth operation of the device. We've delved into the mechanics of resistors, exploring how they use the principle of Ohm's law to function. We've seen how the value of a resistor, measured in ohms, determines the level of resistance it provides. The higher the value, the greater the resistance, and the less current that flows through. Understanding how resistors work is not just a fun fact, it's a fundamental building block for anyone keen on delving into the world of electronics. Whether you're tinkering with a hobby project or designing complex circuits, your journey will be much smoother with this knowledge in your toolbox. And that's the lowdown on resistors. Don't forget to like and subscribe for more illuminating insights into electronics.